So this number grows very quickly. With as little as 60 variables, we're left with this number, which is 1.15 quintillion. So it's a huge number. Even considering that we could build a model every 20 seconds, it would take us 730 billion years to fully test every model that could be produced from these 60 variables. The age of the universe, obviously, is a lot less than that. It's 13.7 billion years. So half the models that you'd be testing wouldn't even include the top variable. 3/4 wouldn't even include the top 2 variables. And 1,023 out of 1,024 wouldn't include the top 10 variables. So there's really a need for feature selection to, most of all, be efficient. It must be an efficient way of identifying the best variables that are available for usage. So a basic feature selection tool, the ones that I'm going to be going through today, can be executed with testing as few as n models and as n times n plus 1 divided by 2 models. So this is a very small number in the grand scheme of things of models, a very small number. With 60 variables, it would be 1,830 models that would need to be tested. In our environment, I mean, that would take 3 to 4 hours. It is sequential steps, so you can't necessarily process against across many machines to accomplish this. So 1,830 models, that's still obviously a ton of models that need to be run. There's a lot of decision points. In these basic feature selections, is usually n decision points. So if you're dealing with 60 variables, there's 60 decision points that would be spread across those 6 hours of processing. So you really can't have a human involved in choosing the outcome of these tests, choosing which variables add the most benefit. You really need to automate not only the building of the models, but also the evaluation of the models. The feature selection algorithms, again, it happens in a sequential order. So the earlier batches, or the later batches, rather, are dependent on the earlier batches. So you really need to either write some SAS or C# code to automate these type of methods that I'll be reviewing. Okay, so the first method that I'll be reviewing is variable shaving. And the reason I'm reviewing this first is because Salford Systems, as part of ProEX, is actually going to be integrating variable shaving, as I term it, into the ProEX version that's coming out. It's very, again, it's very, one of the key benefits is it's very low cost. It's going to be, if you have ProEX, you're not going to need to implement anything. So variable shaving is the stepwise removal of variables from a model just based on the variable importance. So at every step, you start with the fully an unrestricted model. So let's say it includes 228 variables. You run a model. You see what the lowest important variable is. You take it out. You run another model on the 227 variables that are left. And you take out the variable with the lowest importance. And you repeat until you reach a stop condition or until all variables are exhausted. So it's only obviously n steps. It's very fast, 60 variables, 60 models, which is, maybe 20 minutes. For CART or TreeNet? So this is based on, I believe, the TreeNet overall importance, which is over the course of the full tree. Yes, it's backward elimination. I'll be reviewing backward selection. This is purely a derived form of what I'm proposing is backward selection. You can also do this in a forward selection manner, but generally that would take actually more models because you'd have to do a lot of testing. The next method that I'm going to be reviewing is forward selection. This is a stepwise addition of variables to a model based on certain performance criteria. So this typically starts with 0 variables and grows until available variables are exhausted or a stop condition is met. Each step has the following subsets that are repeated up to n iterations. So there's a model testing phase, an evaluation stage, and finally a variable selection phase that's repeated each time. So at each stage, we're testing whether or not a variable adds discriminatory power to the models. So we're actually building a model combining all variables that have already been selected and each available variable. And we're doing this in a test scenario. We're picking the model. We're evaluating the model batch, seeing which variable added the most discrimination overall. We're picking that variable to add to the model. We add it to the model, and we repeat until we run out of variables or a stop condition is met. So this can also be done with, by importance also. It really depends what your performance criteria is. So the sample process, basically, if you consider that we have a variable scope of only 5 variables, let's say their income, age, house value, auto value, and credit score, the first step would concentrate on building the strongest one variable model. So we would build 5 one variable models, and in this case, and then we'd evaluate them. In this case, we see that auto value adds the most discrimination. You see that it has ROC of 0.578, which is higher than the next best, which is credit score with a 0.572 ROC. I'm using ROC here. Really, you could use KS. You could use any other performance metric. Maybe it's R squared, depending on the situation, classification rate. It's really dependent on how your model is going to be evaluated in the end. Generally, we evaluate this metric on the validation data set, not the training data set. And this is just to avoid, obviously, overtraining. So we add auto value into the model, and we proceed to step 2. Step 2, the goal here is to create the strongest 2-variable model. So you can see we create 4 models, each on one of the 4 available variables that are left, combined with the variable that has already been selected. So in this case, we see that credit score offers at this step the most lift in terms of ROC. We select it and proceed to step 3. So this is a process that's continued until we've reached a stop condition or until there's no more variables left. Are there any questions about the process? Or? Okay, so backward selection is basically the same thing as forward selection. It's a stepwise removal of variables from a model based on a decision criteria. Typically, we start with an unrestricted model, and we start testing variable restrictions and figure out how to restrict variables in a model. Again, the substeps are the same. There's a model testing phase, the evaluation phase, and a variable removal phase. Basically, during the model testing phase, we're testing the removal of these variables. So we're pulling the variables out of the model. We're evaluating if there was any performance gain by removing these variables. And if there was, we'll remove them from the model and proceed to the next step.